Hi, in this video we're going to talk about higher order derivatives. And so there's something here at the top of the screen that explains what that is. Essentially, we are finding the derivative of a derivative. So one question might be, why would we do that? We're going to look at that in some of the next sections in our textbook. For right now, we're just going to talk about how to do that and notation that we use to designate that. All right, so what we've done before is a first derivative, and there are a couple of different notations that I've put here on the screen. So one of them is using the prime notation, and so I've got f prime of x here, but you also know that sometimes you might write y prime, for example. You can also use the d dx notation, so probably most often you see that written as dy dx, but you can also see that written as d dx of f of x, or d dx of some specific function, say x squared or something like that. So you've got d dx of a function. So two different kinds of notations, the prime notation and the d dx kind of notation that we use for derivatives, and then extending that to second, third, etc. derivatives. So the second derivative is the derivative of the first derivative. And so when you use the prime notation, you just add a prime to that. So f double prime of x is how we would read that. Or if we're using the y notation, we would write y double prime. That would indicate a second derivative or derivative of the derivative. With the d dx notation, it's a little funny, and sometimes students have a bit of a hard time understanding why these 2's are where they are. But I'm going to write out here to the side, kind of using this d dx of f of x notation. The idea here is that you've got the derivative with respect to x of the derivative with respect to x of a function f of x. So in some ways it's sort of like composition. You've got one thing applied to another thing, applied to another thing. And so the idea here is that you've got two of those d dx's applied to the f of x. So you can also write that as d squared dx squared of f of x. You probably won't see that notation as often. The ones that I typed on the screen, or maybe the y double prime, is probably what you'll see most often. But you just want to be clear about what it means if you do see it written differently. All right, and then a third derivative would be the derivative of the derivative of the derivative, or derivative of second derivative. And so you've got triple prime written there, and so you could certainly write that as y triple prime as well. Using the d dx notation, there would just be a 3 there. So you've got 3 iterations of the d dx applied to your function y. And there might be reasons that you might need a fourth or fifth or sixth derivative and so on. And then sometimes in theorems, you'll think about that in general, an nth derivative in general, or we might call that an nth order derivative. And the primes get unwieldy after a while. You can imagine if you had 10 derivatives, the 10 primes might be kind of unwieldy to write down. So you might write something like this with the parentheses with a 10 in it. And if you just have a y, you would write it like this, an nth order derivative. So those parentheses there would indicate that we're talking about a derivative, not an exponent. And then for the d dx notation, the n would just indicate how many derivatives are applied. All right, so for right now, you're probably mostly going to work with first, second, maybe third derivatives. If you take Calculus 2, you will look at some things that require many, many derivatives, so you'll have these higher order derivatives. And sometimes theorems are stated using an nth order derivative, so you'll see that sometimes written that way. All right, let's look at a couple of examples down here below. We're going to use some shortcut rules to find the first and second derivative of each function. All right, so we already know how to find derivatives. It's just a matter of implementing the rules that we already know and finding the first derivative, and then the derivative of that would be our second derivative. All right, so this is a good time to kind of reflect back on the rules that we know and thinking about how to attack these sorts of problems that might have multiple rules involved. So when I look at this problem that's 31 here, the first thing I'm going to notice is that I have really two terms separated by this addition sign. And so we have a differentiation rule that says that if you have functions that are added to each other, you can differentiate those term by term. So the sum rule for differentiation. So I'm essentially going to chunk this problem into two pieces separated by the addition sign. And then when I look at the stuff that is before the addition sign, I'm going to notice that I have x squared times e to the x. So those are two functions of x that are times each other. So I'm going to need product rule on that part. The part that is after the addition sign, I've got this fraction, and so sometimes students want to use quotient rule on that, but the thing I would notice about that is that I don't really have a function of x on the numerator. It's just a constant, so I don't really need quotient rule when I do that last term. And sometimes students say, well, what difference does it make if I use quotient rule as long as I get the right answer? But it can lead to a lot of mistakes. I see a lot of students make mistakes when they try to use quotient rule and it's not necessary. And it is also pretty inefficient because you end up writing out a lot more steps. So that last term, I don't really need quotient rule. I can just rewrite that as 2x to the negative 1 and then just use power rule. All right, so before I find the derivative, I'm just rewriting my original function, and I'm going to put some parentheses here just to remind myself there's my first and my second function in the product. And then I'm going to separate that at the addition sign. And this last part I'm going to rewrite as 2x to the negative 1. So that's just the original function rewritten a little bit so that I can keep things separate and apply the appropriate rules. All right, so then my first derivative, I'm going to use product rule. So derivative of the first function times the second function plus the first function times the derivative of the second function. All right, so all of that is from product rule on the x squared e to the x when I found the derivative of that part. And then after the addition sign, I'm just going to use power rule. So I'm going to bring down that exponent and subtract 1. So we'll have 2 times negative 1, so that'll be negative 2. I've written plus and negative, but you could just make that minus x to the, and then subtract 1 from the exponent. So negative 1 minus 1 will be negative 2. All right, there's my first derivative, and I can just leave it like that if I want. I can also do some simplifying if I want, since I'm going to go ahead and find a second derivative. I'm going to just rewrite it like that with just cleaning up my plus and negative here at the back. I'm going to go ahead and leave it like this for my first derivative. All right, now when I find the second derivative, I'm going to find the derivative of the first derivative. So I'll write y double prime for that. And again, I want to look at this previous problem and think about how to organize the information. All right, so chunking it at the addition and subtraction signs. So that's term by term differentiation sum rule that you can separate at the addition and subtraction signs. And then I'm going to look at kind of each grouping there and think about what I need. Here I have a function of x times a function of x. So I'm going to need product rule on that. And then after that, I've got x squared times e to the x. I'm going to need another product rule on that. And then at the end here, I'll just have the power rule where I'll bring down the exponent and subtract 1 for that. So 2 product rules in this one. All right, so I'm going to do these product rules in different colors. I'm going to do this first one in pink, and I'm going to do the second one in green, just to keep straight what's happening here in my second derivative. All right, so when I do product rule on the 2x e to the x, I'm going to have the derivative of the first function. So derivative of 2x is 2 times the second function plus the first function times the derivative of the second function. All right, so all of that is product rule on 2x e to the x. And then I'm going to have plus, and then everything that's going to come from product rule on my x squared e to the x. So derivative of the first function times the second function plus the first function times the derivative of the second function. So those two terms are product rule on my x squared e to the x. And then don't want to forget about my minus 2x to the negative 2 here at the end. So I'll just go ahead and do that in purple. And I'm going to have negative 2 times negative 2 will be plus 4x to the, and then subtract 1 from the exponent, so negative 3. All right, there is my second derivative, and it's perfectly fine to type that for an answer or leave that in that form if you don't need to simplify. You might notice that there are a couple of terms here in the middle that are like terms that you could go ahead and combine if you want. So the simplified version here, I would have 2e to the x plus 4x e to the x plus x squared e to the x plus 4x to the negative 3, or if you want, you could write that as 4 over x cubed if you want to write it like that. All right, and especially when you have problems like this where you have the original function and a first and second derivative, it's important that you label your work and your results so that you don't just have things floating around that are unlabeled. You're going to have two different results here. So you've got your first derivative labeled and your second derivative labeled. All right, let's go ahead and look at this next one. On this next one, notice that I've got a function of x divided by a function of x, so I'm going to need to use quotient rule on this. Right? So for my first derivative, f prime of x, I will have the derivative of the top. The 2 just comes along. Derivative of e to the x is itself, e to the x, times the bottom minus the top times the derivative of the bottom. So the derivative of x plus 1, I'm going to think about that as 1x plus 1. Derivative of 1x is 1. And then derivative of the 1 term is 0. So we just have that all over the denominator, x plus 1, the quantity squared. All right, so there's my first derivative. And if all we were doing was finding a first derivative, I would probably just leave it like that and go on. But since I'm going to find the second derivative, this is a good time to go ahead and simplify that first derivative. So I'm going to distribute through my 2 e to the x in this first parentheses, and then this last part is all just one term, so it'll just be minus 2 e to the x. All over x plus 1, the quantity squared, or I'm going to go ahead and expand that out. X plus 1 times x plus 1 is x squared plus 2x plus 1. Don't forget about that middle term when you FOIL that out. All right, and since these terms cancel, I'm going to go ahead and write it like that. All right, so now when I find my second derivative, I'm going to need to use quotient rule because I've got a function of x over a function of x. But I also, on the numerator, have a product of functions. So when I do this one, I'm going to need to be using product rule and quotient rule at the same time. These are the kinds of problems students can easily kind of get lost in. The overall structure of the problem is a quotient. I'm going to write some Q's here. And so I'm going to be using that as my overall structure of the problem. But when I go to take the derivative of the top, that's when I'm going to need product rule. So product rule is going to happen when I take the derivative of the top. And when I go to take that derivative of the top, I'm going to think about that as two factors times each other. So 2x is one of the factors, and e to the x is the other factor. All right, so when I go here to take the derivative of the top, I'm going to enclose that in some brackets because I'm going to have more than one thing here. It's pretty complicated, and all of that comes from the derivative of the top is going to have to be times the bottom. All right, so product rule on the derivative of the top. So I'll have the derivative of the first function, the derivative of 2x is 2, times the second function, times e to the x, plus the first function, 2x, times the derivative of the second function, derivative of e to the x is e to the x. So I need brackets or parentheses around that because all of that is going to have to be times that bottom function in my quotient rule. Problems like this are where it's especially helpful to have written out those cues to yourself so you don't get lost in what you were doing and what you've already taken the derivative of. All right, so at this point now I'm just kind of following my instructions that I already wrote down for myself. I found the derivative of the top, that's where I had to use product rule, times the bottom minus, and now I just need to write down the top function. And now I'm going to take that times the derivative of the bottom function. So derivative of x squared plus 2x plus 1 will be 2x plus 2. And then all over that bottom function squared. All right, and at this point I could leave my answer like that. If you really want to expand things out, you can do that. You probably have some terms you can combine or cancel with each other. I'm going to go ahead and leave it like this, but you can feel free to simplify if you want.